All right, today we're doing Chapter 12, Section 6, which is the Law of Cosines. It's one of the California Trigonometry Standards 13. You've got to know the Law of Sines, which we'll pick up on another day, and the Law of Cosines and how to apply problems. So today's objective is to use the Law of Cosines to find sides and angles of triangles. Now, here is the important feature that we need to be aware of. Do not apply the law of cosines if it is a right triangle. Only apply the law of cosines when it is not a right triangle. When it is not a right triangle, you cannot use the regular 6 trig ratios like we did in the previous section 12.5. Those will not work. So this is the law of cosines. I think there's 3 variations based on the letters of the triangles, and we'll show you that in just a second, so let's look at it. And let me explain these 3 variations. A squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. And in that case, you are either solving for side A or you are solving for angle A. The second scenario is b squared equals a squared plus c squared minus 2ac times the cosine of b, and you are either solving for side b or angle b in that variation. Likewise, I think you can figure out c squared equals a squared plus b squared minus 2ab times the cosine of angle c. You are either solving for side c or angle c. So it's essentially the same formula, it's just which side or which angle you're looking for. The side that's isolated by itself corresponds with the angle that we have the cosine of. So let's look at a particular situation. And yes, this is not a right triangle, and my first guess is because one of these angles is 115 degrees. So as we look at this, here's triangle ABC. Now, on the tests and in the homework, they try not to be as careful as I am. I'm being careful right here by putting in parentheses it is not a right triangle. What you need to look for is if it says it is a right triangle, it is, and if they don't say it is, then it's not. So we have side A is 24, side C is 32, angle B is 115. Find side B. So in our triangle A, B, and C, angle B is 115 degrees. Side B is opposite angle B. Side A is 24, that's opposite angle A. Side C is 32, that's opposite angle C. Now, here's the situation for law of cosines. For non-right triangles, there's really 2 applications you're looking for. We have 2 sides in the included angle. Now, we're not doing a geometric proof, but remember side angle side from geometry? So here's what essentially you're looking when to use the law of cosines. It's not a right triangle, and one scenario is you have side angle side, and you're looking for the side opposite the angle you were given. That's when you would apply the law of cosines. So let's start by writing the formula down. In this case, we're looking for side B, so we're taking the variation b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Let's fill in all the information we know. A is 24, C is 32. 2 still stays part of the formula. A is still 24, C is still 32, and angle B is 115 degrees. So let's square our numbers. 24 squared is 576. 32 squared is 1,024. 2 times 24 times 32 is 1,536. And now let's look up the cosine of 115. That's in quadrant 2. Your calculator knows that cosine in quadrant 2 is negative. So when you type 115, hit the cosine button, you will get negative 0.4226 when you round it to 4 places. All right, and then 576 plus 1,024 is 1,600. And I need to do this multiplication before I subtract. So to multiply 1,536 times negative 0.4226 gives me negative 649.1136. And when I'm subtracting a negative, that is the same as adding a positive. And we add those 2 numbers together, 1,600 plus 649.1136, we get 2,249.1136. But that is b squared. So to get b, we hit the square root button. Now I didn't write down the step taking the square root of both sides, but you know that's the step that we have to do. The square root of 2,249.1136 to 4 places is 47.4248. And usually sides of a triangle, we just go to 1 decimal place, so 47.4. So that's using the law of cosines to find side B. Now let me just for a second state the obvious. Some students in the past have tried to do the Pythagorean theorem. Why can we not use the Pythagorean theorem? It's not a right triangle. All right, so the law of cosines to the rescue when it's not a right triangle. All right, let's do another example. And in this situation, here's the second scenario where the law of cosines comes into play. And that second scenario is when you know all 3 sides of a triangle, it's not a right triangle, and you are looking for one of the angles. Now again, we're not doing geometry proofs with triangles, but in that language, the lingo of geometry, it's like a side, side, side. We have all 3 sides, and we're looking for an angle. And so in this case, we're looking for, we've got triangle ABC. Side A is 18, that's opposite angle A. Side B is 25, that's opposite angle B. Side C is 12, that's opposite angle C. And since we're looking for angle B, we again use the variation b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Now, let's fill in what we know. B is 25, A is 18, C is 12, 2 is still 2, A is 18, C is 12, and we have to find the cosine. But you'll notice I added some brackets around here. And I did that on purpose so that students won't make a careless mistake. And I'll talk about that as we get further in this problem. 25 squared is 625, 18 squared is 324, 12 squared is 144. 2 times 18 times 12 is 432. And again, I still have my brackets here. And I'll tell you now why I have those brackets there. This is 432 times the cosine of angle B. Some students, when they simplify, because we've got to add 324 and 144, they get a little carried away, and they would subtract 432. But you can't. This is 432 times the cosine of B. This is like 432 times x. You can't combine those with constants. So we can add 324 and 144 to get 468. And again, I want to make sure we don't subtract the 432 from it because that's times the cosine of B. But we do want to get B by itself, and we do want to undo addition by 468. So we're going to subtract 468 from both sides. Now, I didn't write down minus 468, but 625 minus 468 is 157, and that equals negative 432 times the cosine of angle B. Now, this is multiplication. To undo multiplication, I need to do division, so we're going to divide both sides by negative 432. And that gives me negative 0.3634 is the cosine of angle B. Now, this brings us to our previous lesson where we were playing the mystery game. We thought of some mystery angle. We typed it in, hit the cosine button, and this was our answer. And so to do that from yesterday, we had to hit the inverse cosine button on our calculators. Do we need to see that again? Well, let's take a quick look at it maybe on the calculator that comes with the computer here. So I'm going to type in 0.3634. I'm going to hit the plus or minus button to make that a negative. And then I'm going to press the inverse button before the cosine. And we're going to round our answer off to 1 decimal place, which is good enough for sides of triangles. So angle B is 111.3 decimal degrees. So in this situation, again, we had all 3 sides. We're looking for one of the angles. It's not a right triangle, so that's another application of the law of cosines. Angle B was 111.3. So to summarize, When to use the law of cosines? First of all, when it's not a right triangle, and you either have SAS, and you're looking for the side opposite that angle, or you have all three sides, and you're looking for one of the angles, as we've just seen in the previous two lessons that we did above. All right, and that's law of cosines for today. Our next episode will be law of sines, because we don't always have side angle side. We don't always have side 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 when we don't have right triangles.